November 8th, 1942. The pre-dawn darkness off the Moroccan coast erupted with tracer fire and explosions as Operation Torch, the Allied invasion of North Africa, commenced. Major General George S. Patton, commanding the Western Task Force, watched from the deck of the USS Augusta as his forces stormed ashore at Casablanca. Within 72 hours the port city was secured, but what American engineers found horrified them. The French had scuttled 42 ships in the harbour, blocking every deep-water berth. The Germans, anticipating Allied use of the port, had systematically demolished every crane, warehouse, and loading facility. Railroad tracks were torn up, fuel storage tanks punctured and burned, electrical systems destroyed. The port's capacity, once capable of handling 2 million tons annually, was reduced to zero. Standing in the wreckage, French harbour officials told American engineers the port would require at least 18 months to restore basic functionality, possibly 3 years to reach pre-war capacity. Colonel John Rattay, commanding the 1st Engineer Special Brigade, looked at the twisted steel and sunken ships and reportedly laughed. He told his staff to inform Patton the port would be operational in 2 weeks. The French thought he was insane. They had no idea what American industrial engineering could achieve. By November 25th, exactly 17 days after the invasion, the first Liberty ship was unloading cargo at a restored Casablanca berth. Within 30 days, the port was handling 12,000 tons daily, exceeding its pre-war capacity. Within 90 days, throughput reached 35,000 tons per day, nearly double what French engineers had considered maximum capacity. German intelligence, receiving reports of Casablanca's restoration, initially refused to believe them. It was impossible. No nation could rebuild that quickly. But the reports kept coming, each more incredible than the last. The pattern would repeat across 3 continents: Cherbourg, Antwerp, Manila, dozens of ports destroyed by retreating enemies, each restored by American engineers at speeds that defied belief. This is the story of how American Engineering Corps transformed port restoration from an 18-month endeavour into a 3-week operation, how industrial logistics defeated military demolition, and how German commanders discovered that destroying infrastructure only delayed the Americans, never stopped them. The United States entered World War II with virtually no expertise in rapid port reconstruction. The Army Corps of Engineers had built dams, bridges and highways, but amphibious operations and port seizure were theoretical exercises. That changed on December 7, 1941. Within weeks of Pearl Harbor, the War Department established the Engineer Special Brigades, dedicated units trained specifically for amphibious operations and port reconstruction. But training soldiers was the easy part. The real challenge was developing the equipment, techniques, and logistics to rebuild destroyed ports under combat conditions. The solution came from an unlikely source: American commercial construction companies. The Corps of Engineers recruited executives from firms like Bechtel, Morrison Knudsen, and Brown and Root, companies that had built the Hoover Dam, the San Francisco Bay Bridge, and countless other massive projects. These men understood industrial logistics, heavy equipment operation, and most importantly, how to organize thousands of workers to accomplish seemingly impossible tasks on brutal deadlines. They brought with them a uniquely American approach to engineering. If you can't fix it, build around it. If you can't build around it, bring bigger equipment. Lieutenant Colonel Paul Thompson, a former Bechtel executive commissioned directly into the Corps of Engineers, established the doctrine that would guide all future port operations. Speed is everything. A port operating at 20% capacity in 1 week is worth more than a port at 100% capacity in 6 months. Accept temporary solutions. Perfect is the enemy of operational. Every decision was evaluated on a single metric. How quickly could cargo flow from ship to shore? Aesthetic concerns, permanent construction, even safety regulations that would slow progress, all were subordinated to speed. The first test of these principles came at Casablanca. The scale of destruction was comprehensive. The main breakwater had been bombed, allowing Atlantic swells to surge into the harbour. 42 vessels ranging from small fishing boats to the 35,000-ton battleship Jean Bart lay sunk or capsized, blocking channels and berths. Every crane was toppled, their structures cut with demolition charges. Warehouse roofs were collapsed, walls blown out. The electrical grid was dead, the water system ruptured, the rail connections severed. French engineers surveying the damage estimated 15,000 man-days just to clear the sunken ships, another 30,000 to rebuild the cranes, 50,000 more to restore the warehouses and support infrastructure. Using traditional methods and available local resources, 18 months was optimistic. The Americans brought neither traditional methods nor local resources. On November 12th, 4 days after the invasion, the 1st Engineer Special Brigade equipment arrived. LSTs, landing ship tank, beached themselves directly on the sand and dropped their bow ramps. Out-rolled equipment the French had never seen in such quantities. D8 Caterpillar bulldozers, each weighing 15 tons with 130 horsepower diesel engines. Carryall scrapers that could move 10 cubic yards of earth in a single pass. International Harvester TD18 tractors pulling pneumatic compactors. Letourneau electric wheel scrapers, revolutionary machines that could load, haul and dump without stopping. But the real revelation was the cranes. American engineers didn't bother trying to repair the destroyed German and French cranes. Instead, they brought their own, shipped in pieces aboard Liberty ships and assembled on site. The Navy's Seabees, cranes, cargo boom cranes, could lift 40 tons and were specifically designed for rapid assembly. A crew of 30 men could erect a Seabees crane in 36 hours, less time than it took to survey the damage to a destroyed conventional crane. More impressive were the mobile cranes, truck-mounted and crawler-mounted units that could drive off LSTs and begin working immediately. The French had never seen mobile cranes of such capacity. American units could lift 20 tons while driving at 15 miles per hour, positioning themselves anywhere without rail tracks or permanent installation. Colonel Rattay's plan for Casablanca was brutally simple. Ignore the blocked main harbour initially, create new berthing capacity using the beach itself. The engineers bulldozed sand ramps directly into the Atlantic, creating causeways where LSTs could beach and unload. Cargo was transferred from ships to shore without need of cranes or piers. Within 48 hours of the invasion, supplies were flowing across these improvised beaches at 2,000 tons per day, more than enough to sustain Patton's forces driving inland. Simultaneously, salvage operations began in the harbour. The Americans brought specialised equipment, diesel-powered centrifugal pumps capable of moving 3,000 gallons per minute, floating cranes that could lift 150 tons, cutting equipment using oxyacetylene torches, fed by compressed gas cylinders the size of telephone poles. The approach to clearing sunken ships was revolutionary. Instead of attempting to raise intact vessels, which required careful planning and weeks of preparation, American salvage crews simply cut them apart underwater. Divers using surface-supplied air and hydraulic cutting shears sliced through ship hulls like butchers sectioning beef. The pieces were lifted by floating cranes and deposited outside the harbour entrance. A 5,000-ton freighter that would take 6 weeks to raise conventionally could be cut into 20 sections and removed in 5 days. The French were appalled at this apparent waste. Those ships could have been restored, they protested. American engineers were unmoved. The ships were blocking the harbour, therefore they were obstacles, not vessels. Obstacles got removed, not restored. By November 20th, 2 critical deep-water berths were cleared. The Americans didn't rebuild the destroyed permanent piers. Instead, they drove LSTs directly against the seawall and used them as floating piers. Cranes positioned on the seawall lifted cargo from the LST decks. When one LST was empty, it backed away and another took its position. No reconstruction needed, no time wasted. The system was inefficient by peacetime standards, requiring more ships and more crane operations than a proper pier. But it was operational immediately, and in war, immediate and inefficient beat perfect and delayed every single time. The restoration of cargo handling capacity followed similar principles. The destroyed warehouses were ignored. American engineers simply created open storage areas. Bulldozers scraped and levelled fields near the port, laid down pierced steel planking for all weather surfaces, and erected nothing more than chain-link fences for security. Cargo was stacked in the open under tarpaulins, guarded by military police. Was it ideal? No. Did it work? Absolutely. The electrical system restoration demonstrated American industrial capacity. Rather than repair the destroyed French power grid, engineers brought their own portable diesel generators, massive units producing 500 kilowatts each. Within a week, the port area had more electrical capacity than before the invasion, all from generators that could be moved or replaced in hours. Lighting was provided by portable light towers, trailer-mounted units with multiple 1,000-watt lamps powered by their own generators. The port operated 24 hours a day under artificial illumination, bright enough to read a newspaper at 100 yards. By late November, the throughput numbers stunned even American planners. Casablanca was handling 12,000 tons daily, more than required to support not just Patton's forces, but the entire North African campaign. French officials, watching American efficiency, were forced to confront an uncomfortable reality. The port was operating better under temporary American systems than it had under permanent French infrastructure. The reason was purely operational philosophy. French ports had been designed for commercial efficiency, minimizing labor costs through mechanization and permanent installation. American military ports were designed for maximum throughput regardless of labor or equipment costs. If a task required 100 men instead of 10, the Americans used 100 men. If equipment was damaged through overuse, they replaced it. Speed was everything, cost was irrelevant. This philosophy was backed by resources that seemed unlimited to European eyes. Equipment broke? There were spares aboard every supply ship. Need more cranes? They arrived within days. Running low on steel planking, millions of square feet were in production stateside. The contrast with German logistics was stark. When German forces demolished ports during retreats, they assumed destruction was permanent because their own logistics couldn't support rapid reconstruction. They had limited heavy equipment, scarce raw materials, overstretched transportation networks. If they destroyed something, it stayed destroyed. The Americans operated in a different reality, where industrial production was so vast that equipment was essentially disposable. The lessons from Casablanca were codified into doctrine before the port was even fully operational. The engineer school at Fort Belvoir, Virginia received detailed reports and began training new units in the techniques. More importantly, equipment manufacturers received orders for specialized port reconstruction equipment based on Casablanca experience. By mid-1943, American industry was producing equipment specifically designed for rapid port reconstruction. The M2 Treadway Bridge, aluminum sections that could be assembled into bridges or piers without welding or bolting, just pinned connections, causeway sections, steel boxes that could be floated into position and ballasted to create instant piers, Bailey Bridge components, modular steel sections that could create bridges capable of supporting 70-ton loads, assembled by hand crews in days. But the real preparation was in pre-positioning. Before any amphibious operation, specialized ships were loaded with port reconstruction equipment in precisely the order it would be needed. These ships, nicknamed jumbo repair ships, carried everything required to restore a port: cranes, bulldozers, generators, pumps, cutting equipment, steel planking, all loaded so the first equipment off the ship was the equipment needed for the first task. The invasion of Sicily in July 1943 demonstrated how far American capabilities had advanced. The ports of Syracuse, Augusta, Palermo and Messina were all targeted. Italian demolitions were thorough. German engineers had supervised and ensured maximum destruction. At Syracuse, American engineers arrived to find 23 sunken ships blocking the harbour, every crane destroyed, all warehouses burned, and the mole, the main breakwater, heavily damaged by explosive charges. Captain Raymond Wheeler, commanding the port reconstruction team, established his command post in a shell-damaged building overlooking the harbour on July 10th, the day of the invasion. He gave his men 10 days to achieve 5,000 tons daily throughput. They did it in 6. The techniques refined at Casablanca were executed with mechanical precision. Beach causeways established within 24 hours, LSTs used as floating piers within 48 hours, first deep water berth cleared within 96 hours. The sunken ships were cut apart so rapidly that Italian divers watching from shore reported they couldn't believe their eyes. Ships that had taken months to build were reduced to scrap in days. But Syracuse revealed a new challenge. The Germans had begun using a more sophisticated demolition technique, time-delayed charges hidden in structural foundations. These would detonate days or weeks after occupation, destroying rebuilt facilities. American engineers developed a brutally simple counter. Every structure was assumed to be booby-trapped, so instead of occupying existing buildings, they bulldozed everything. Warehouses, office buildings, Even portions of the seawall that might contain charges, all were pushed into rubble piles and hauled away. Then Americans built their own temporary structures, prefabricated buildings shipped in sections. The port facilities that emerged bore no resemblance to the pre-war Italian infrastructure, but they processed cargo at triple the rate. By August, Syracuse was handling 18,000 tons daily, more than the combined capacity of all Italian ports in Sicily before the war. German intelligence reports from Sicily revealed growing alarm. Oberst Heinrich Ritter, a logistics officer with the Hermann Göring Division, reported to Berlin in August 1943. His report was captured when he was killed at Salerno. The Americans have solved the port problem. We destroyed Syracuse thoroughly, every facility demolished according to engineering doctrine. Within 1 week, they were unloading more cargo than when the port was intact. Within 2 weeks, their throughput exceeded anything we thought possible. Their methods are wasteful by our standards. They use 10 times the men and equipment we would allocate, but their results are undeniable. More concerning, they seem to have unlimited quantities of specialized equipment. Where we have 1 floating crane, they have 20. Where we have a dozen bulldozers, they have 200. Our demolitions buy us days, not weeks. Days during which American combat power accumulates faster than we can respond. The invasion of mainland Italy in September 1943 brought the ultimate test at Salerno and Naples. Naples, one of Europe's great ports with capacity for 2 million tons annually, was demolished so thoroughly that German engineers claimed it would be unusable for a year. General Heinrich von Wittinghoff, commanding German forces in southern Italy, ordered comprehensive destruction. Every quay was cratered with 1,000-pound bombs, every warehouse burned, every crane toppled into the harbour. Over 130 ships were scuttled in the harbour and approaches, blocking every channel. The railroad facilities were destroyed, bridges dropped, tunnels collapsed. But the masterpiece of German demolition was the breakwater mole. Engineers placed massive charges in the foundation, creating a gap 100 yards wide that allowed Mediterranean storms to surge directly into the harbour. Without the breakwater's protection, the inner harbour was unusable in any weather, even if everything else was repaired. Von Wittinghoff considered Naples' elimination his greatest success in the Italian campaign. In his estimation, denying the Americans a major port would limit their logistical capacity and delay any advance northward for months. He was wrong. Major General John C. H. Lee, commanding the services of supply for Fifth Army, surveyed Naples harbour on October 1, 1943, the day the city was secured. German demolitions were still detonating, time-delayed charges destroying structures as American troops watched. Lee's assessment was delivered to General Mark Clark within hours. The port can handle 3,000 tons daily within 1 week, 10,000 tons within 3 weeks, full pre-war capacity within 2 months. Clark, familiar with American engineering capabilities from North Africa and Sicily, approved the timeline and ordered Lee to exceed it if possible. What happened over the next 60 days became legendary in engineering circles and remains one of the most impressive reconstruction efforts in military history. The first American equipment arrived in Naples harbour on October 2nd, just 24 hours after occupation. The 1st Engineer Special Brigade brought 2 LSTs loaded with bulldozers and a floating crane. They didn't wait for permission or surveys, they simply began clearing the nearest quay of debris. By October 4th, the first Liberty ship was unloading cargo using the LST as pier method, just 3 days after the city fell. But this was the easy part. Makeshift solutions using American improvisational doctrine. The real challenge was the sunken ships and the destroyed breakwater. The ship clearing operation at Naples was the largest salvage effort in history to that date. 130 ships ranging from 200-ton coasters to the 12,000-ton passenger liner Conte de Savoia blocked the harbour. Using conventional salvage methods and assuming ideal conditions, clearing would require 18 months minimum. The US Navy's salvage assessment estimated 24 months. Colonel Harry Barden, commanding the harbour clearance operation, had a different estimate. 6 weeks, 8 if weather turned bad. His plan was pure American industrial warfare. Ignore the ship's potential value, treat them as obstacles, cut them into pieces small enough to lift with available cranes, remove the pieces, move to the next ship, repeat until the harbour is clear. The cutting crews worked in 3 shifts, 24 hours a day. Divers descended with hydraulic shears that could cut through 2-inch steel plate, oxyacetylene torches that burned underwater, and shaped demolition charges for the heavier structural members. On the surface, floating cranes waited to lift sections as soon as they were freed. The efficiency was staggering. The Conte di Savoia, which would have required months to raise intact, was cut into 47 sections and removed in 11 days. The destroyer Euro, scuttled in a critical channel, was cleared in 38 hours. The methods appalled traditionalists. Ships that could have been restored with effort were being destroyed permanently. Valuable material was being dumped at sea rather than salvaged. Naval architects watching the operation compared it to vandalism. But the cargo throughput numbers silenced critics. Each day of delay cost the Fifth Army 5,000 tons of supplies, ammunition, food, fuel, everything needed to sustain offensive operations. Every ship removed opened more berth space, increased capacity, accelerated the advance northward. The destroyed breakwater presented a unique challenge. Repairing it conventionally would require thousands of tons of concrete, specialized construction equipment, and months of work. The gap allowed swells that made the inner harbour unusable whenever wind exceeded 15 knots, roughly half the days in a typical Mediterranean autumn. American engineers considered the problem and implemented a solution that Italian engineers had deemed impossible. They sank 5 Liberty ships in the gap as a temporary breakwater. The ships were stripped of useful equipment, towed into position, and deliberately sunk, creating an artificial barrier. The gaps between. The ships were closed with Navy pontoon sections, large steel boxes ballasted with sand. The entire operation took 9 days. Italian officials protested that it was a temporary solution that would fail in the first major storm. American engineers agreed completely. It was temporary, it probably would fail eventually, and they didn't care. It needed to work for 6 months while the advance continued northward. After that, Naples would become a secondary port and its long-term reconstruction could be accomplished at leisure. The temporary Liberty ship breakwater functioned perfectly for 8 months before winter storms damaged it. By then, American forces were north of Rome, and Naples' role in the campaign had diminished. The pre-war breakwater was eventually restored in 1947 by Italian engineers, 4 years after the American temporary solution was implemented. By November 1st, just 30 days after occupation, Naples was handling 7,500 tons daily. By December 1st, throughput reached 15,000 tons. By January 1944, the port was processing over 25,000 tons daily, exceeding its pre-war capacity despite still being only partially cleared. The numbers seemed impossible to German intelligence. Oberst Johannes Berndt, a logistics officer with 10th Army, reported to Field Marshal Kesselring in December 1943. His report survives in captured German documents. The Americans have restored Naples to beyond pre-war capacity in under 60 days. Our engineers estimated a year would be required. We were not merely wrong, we were operating in a different reality than the Americans inhabit. Their equipment arrives in quantities we cannot comprehend. At any given time, there are 30 to 40 floating cranes in the harbour, each capable of lifting more than anything we possess. Their cutting equipment processed sunken ships at a rate of 2 per day during peak operations. They have portable generators providing more electrical power than the entire city consumed before the war. Most concerning for our operational planning, they appear to have solved the logistics limitation problem. We calculated that even with Naples operational, the Americans would be limited to supporting 6 divisions in sustained combat due to transportation and storage constraints. They are currently supporting 11 divisions and increasing. Their solution was simple but beyond our capability to replicate. They don't store supplies, they flow them. Trucks arrive at the port, load directly from ships, drive to frontline units, and return. There are no intermediate depots, no storage facilities, no delays. It is inefficient by our standards, requiring enormous numbers of vehicles and fuel, but their production makes such inefficiency irrelevant. We operate on European logistics, carefully managed resources distributed through efficient systems. They operate on American logistics, overwhelming quantities moved by brute force. In a war of attrition, brute force is winning. The techniques perfected in Italy were systematized and distributed throughout the army. The engineer school developed specific courses on rapid port reconstruction. More importantly, dedicated equipment was now in mass production. The Navy commissioned specialized salvage ships, the diver-class vessels specifically designed for harbor clearance. Each carried complete cutting and lifting equipment, could accommodate 100 divers and salvage personnel, and had workshops capable of fabricating specialised tools on site. The Army developed the Transportation Port Company, specialised units of 500 men, each trained specifically in cargo handling. These units could arrive at a newly captured port and begin operations immediately, without local labour or pre-existing infrastructure. Everything they needed arrived with them: forklifts, trucks, cranes, even portable shower and latrine facilities. But the real preparation was in equipment pre-positioning. Before the Normandy invasion, specialised supply ships were loaded with equipment specifically for Cherbourg, which was expected to be heavily demolished. These ships contained everything that Casablanca, Syracuse and Naples' experience had shown would be needed: 30 floating cranes, 60 bulldozers, 40 mobile cranes, complete salvage equipment for 50 ships, enough steel planking to surface 50 acres, portable generators totaling 5 megawatts capacity, enough Bailey bridge sections to construct a mile of bridging, and 10,000 tons of specialised tools and supplies. This equipment was in addition to standard combat engineer equipment and was specifically allocated for port reconstruction. The ships carrying it were positioned to enter Cherbourg immediately upon capture. The Germans, aware that Cherbourg would be a critical Allied objective, prepared demolitions under the personal supervision of Admiral Walter Hennecke, naval commander for Normandy. Hennecke was a thoroughgoing officer who understood demolition science. His plan was the most comprehensive port destruction ever attempted. Every quay would be mined with charges placed every 20 feet. Every crane would be toppled and its tower cut with explosives. Every warehouse would be burned with incendiary charges. The outer mole would be breached in 4 places with 2,000-pound bombs. Every ship in the harbour, military and civilian, would be scuttled. But Hennecke went further. He placed time-delayed charges throughout the port facilities, set to detonate days or weeks after capture. He mined the approaches with contact and magnetic mines so densely that minesweeping would require weeks. He destroyed the lock gates that protected the inner harbour from tidal variations, allowing the extreme tides of the Normandy coast to render the inner harbour unusable. Most ingeniously, he placed concrete obstacles weighing up to 10 tons throughout the harbour, positioned to block navigation channels and prevent salvage operations. These obstacles, called Rommelsparagus by German troops, were designed to be too heavy to lift easily and too hard to cut through quickly. Hennecke's demolitions were executed beginning June 21, 1944, as American forces approached the city. German engineers worked methodically, following checklists developed over years of retreat across Russia and Italy. By June 26th, when American troops entered Cherbourg, the port was devastated beyond anything previously encountered. General Joseph Collins, commanding 7 Corps, surveyed the damage and estimated 6 months to achieve any meaningful cargo capacity. His engineers were more pessimistic, suggesting 8 months to a year. Naval officers examining the wreckage agreed Cherbourg was destroyed so thoroughly that alternative ports might be faster. They were all wrong. Colonel Alvin Viney, commanding the 1049th Port Construction and Repair Group, arrived at Cherbourg on June 27th, with advance elements of his command. His assessment differed dramatically from earlier estimates. The port would be handling cargo within 2 weeks, achieve 10,000 tons daily within 1 month, reach pre-war capacity within 3 months. When challenged on these estimates, Viney's response was recorded in the Corps of Engineers official history. "We've done this before at Casablanca, Syracuse, Naples. Cherbourg is worse, but we're better. The equipment we have now didn't exist in 1942. The techniques we've developed are proven. The men have done this enough times that it's routine. Give me the resources and stay out of my way." The resources arrived in overwhelming quantity. Within 48 hours, the first equipment ships were unloading directly onto the beach north of the damaged port. By July the 2nd, over 500 pieces of heavy equipment were operating in and around Cherbourg. The scale was unprecedented. 60 bulldozers worked simultaneously clearing rubble. 30 floating cranes began lifting the Rommelsparagus obstacles, which proved easier to remove than Hennecke anticipated. American cranes could lift 10 tons easily, and the obstacle positioning actually helped by showing salvage crews exactly where navigation channels needed to be cleared. The mine-clearing operation demonstrated American thoroughness. The Navy deployed 40 minesweepers that worked around the clock in shifts. Rather than slowly sweeping traditional search patterns, American doctrine was to saturate an area with sweepers until no mines remained. If traditional doctrine said 10 sweeps guaranteed clearance, Americans made 50 sweeps. The result was slower initial progress but absolute certainty. Within 10 days, safe channels were marked and operational. The time-delayed charges that Henniker had carefully positioned proved more nuisance than obstacle. American doctrine assumed everything was booby-trapped, so engineers didn't attempt to occupy German buildings or use German infrastructure. When charges detonated in empty, already destroyed structures, they accomplished nothing. The few charges that detonated in areas, Americans were using cause casualties but didn't significantly delay operations. Casualties were simply replaced from the stream of reinforcements arriving daily. The destroyed lock gates that were supposed to make the inner harbour unusable were bypassed using American ingenuity. Engineers constructed a cofferdam using steel sheet piling driven into the harbour bottom, creating a protected area independent of the lock system. The cofferdam enclosed enough water to accommodate 6 Liberty ships simultaneously and could be pumped out for maintenance between tidal cycles. It was a temporary solution that required continuous pumping, consumed enormous amounts of fuel for the pumps, and needed constant maintenance. It also worked perfectly and rendered Henniker's lockgate demolitions irrelevant. By July the 16th, just 20 days after capture, the first Liberty ship was unloading at a reconstructed Cherbourg berth. By August 1st, throughput reached 8,000 tons daily. By September 1st, Cherbourg was handling 20,000 tons per day, making it one of the busiest ports in Europe. The speed stunned everyone, including American planners who had considered Vigny's estimates optimistic. German reaction was captured in an interrogation report of Rear Admiral Henniker, taken prisoner in Cherbourg. When shown photographs of the operational port in August, his response was recorded. "This is not possible. I personally supervised the demolitions. Every facility was destroyed according to the most advanced demolition science. The locks were blown, the quays mined, the harbour blocked with obstacles and sunken ships. The Americans would need 6 months minimum, more likely a year. I was told in Berlin that Cherbourg's destruction would delay the American advance for the entire summer, possibly force them to bring all supplies over the beaches indefinitely. But looking at these photographs, the port is not just operational, it's busier than when we held it. The cranes are different, the buildings are different, even the layout is different, but it's working. More than working, it's thriving. The Americans didn't rebuild our port, they built their own port on the ruins of ours, and they did it in weeks. How is this possible? What resources do they have? How many men? How much equipment? This changes everything about defensive strategy. If we cannot deny them ports, if demolitions only delay them by weeks instead of months, then every coastal defense becomes temporary. They will always have the logistics to continue. We are not fighting an army. We are fighting an industrial system that treats ports like disposable infrastructure. When interrogators asked Henniker what could have been done differently, his answer was bleak. Nothing. Perhaps more thorough demolitions would have bought another week, maybe 2. But fundamentally, the Americans have solved a problem we thought was unsolvable. They move equipment in quantities we consider wasteful. They use methods we consider crude. They ignore engineering principles we consider fundamental. And they achieve results in 1 month that would take us 6 months, if we could do it at all. The Germans are discovering what the Japanese learned in the Pacific. American industrial capacity is not just greater than ours, it operates by different rules. They don't optimize for efficiency, they optimize for speed. They don't minimize resources, they apply overwhelming resources. In a long war of attrition, their approach wins. Cherbourg was being rebuilt while the Battle of Normandy still raged. The psychological impact on German commanders was profound. If ports couldn't be denied, if demolitions were merely temporary inconveniences, then the entire defensive strategy of trading space for time was undermined. By October 1944, American forces were approaching another critical port, Antwerp, Belgium. This was the big one, the greatest port in Europe with pre-war capacity of 10 million tons annually. Antwerp's facilities dwarfed any port yet encountered. 30 miles of quays, 600 cranes, 1,000 warehouses, rail connections to all of Europe. Its capture intact on September 4th by British forces was one of the greatest coups of the war. The port was almost undamaged, German forces retreating so rapidly they had no time for thorough demolitions. But Antwerp had a unique problem. It was located 50 miles up the Scheldt estuary from the North Sea. The Germans still held both banks of the Scheldt, making the port unusable despite being captured intact. Every ship approaching would be destroyed by German coastal artillery. The Allies needed to clear the Scheldt, a major military operation that took until November the 28th. When minesweepers finally completed clearing the river approaches and the first convoy could reach Antwerp, German commanders expected demolitions to begin. Their forces were retreating but still within V2 and artillery range. Surely they would destroy the port before it could be used against them. General Oberst Kurt Student, commanding German forces in the Netherlands, received orders to destroy Antwerp by any means available. Artillery fire, V2 rockets, V1 flying bombs, commando raids, anything to demolish the port facilities before they could support the Allied advance. Student launched everything available. V2 rockets struck the port area throughout December, each carrying a 1,900-pound warhead. V1 flying bombs were redirected from London to Antwerp. Long-range artillery hammered the facilities whenever they came in range. The attacks killed over 200 civilians and military personnel and damaged numerous buildings and ships, but they failed to significantly impact port operations. The reason was simple scale and redundancy. Antwerp was so vast that even heavy weapons caused only localized damage. A V2 rocket that destroyed a warehouse eliminated 0.1% of Antwerp's storage capacity. Destroying a crane eliminated one of 600. The Americans simply worked around damage, routing, cargo to undamaged facilities. More importantly, American reconstruction capabilities now exceeded German demolition capabilities. When a V2 cratered a quay, American engineers filled the crater and restored the surface in 2 days. When a warehouse was destroyed, prefabricated buildings were erected nearby in a week. The Germans were demolishing as fast as they could, the Americans were rebuilding faster. By December 15th, Antwerp was handling 15,000 tons daily. By year's end, throughput reached 35,000 tons. By January 1945, the port was processing over 60,000 tons daily, more than all other Allied ports in Europe combined. The supplies flowing through Antwerp were sustaining over 60 Allied divisions, the largest military force ever assembled. Students' assessment delivered to General Alfred Jodl in January 1945 captured German despair. We have thrown everything at Antwerp. Rockets, bombs, artillery, commando raids. We have killed thousands and destroyed dozens of facilities. The port operates at greater capacity every week. I watch reconnaissance photographs showing the damage we inflict, and the next day's photographs show it repaired. We cratered the quays with V2s, they filled the craters faster than we could create them. We destroyed warehouses, they built new ones. We sank ships in the harbour, they cleared them in days. The Americans have more reconstruction capacity than we have destruction capacity. This is not a military problem, it's a mathematical problem. We are attempting to empty the ocean with a bucket. The Antwerp operation represented the full maturity of American port reconstruction capability. Every lesson from 3 years of operations across 2 theatres was applied. The result was a system that could absorb enemy action and continue functioning, the exact opposite of traditional port operations that were vulnerable to any disruption. In the Pacific Theatre, similar patterns were emerging. The capture of Manila in February 1945 presented the worst port destruction yet encountered. General Tomoyuki Yamashita, commanding Japanese forces in the Philippines, ordered Manila's complete destruction. Unlike European demolitions that were militarily rational, focused on denying facilities, the Manila destruction was vindictive, intended to punish Filipino civilians for welcoming Americans. The Manila waterfront was systematically destroyed over 3 weeks. Japanese engineers used 5,000 tons of explosives, more than had been used in any previous demolition operation. Every pier was blown up, dropping thousands of tons of concrete into the harbour. Every warehouse was burned with incendiary charges. Every crane was toppled and then blown apart. Ships were not just scuttled, they were blown up with charges that split their hulls completely. The harbour master's records were burned, making it impossible to know where ships had been sunk or what condition the bottom was in. Most devastatingly, the Japanese destroyed the sea walls and breakwaters that protected the harbour, exposing it fully to Pacific typhoons. American engineers arriving in early March found conditions worse than any European port. General Hugh Casey, MacArthur's chief engineer, surveyed the wreckage and submitted an estimate, 8 months to achieve basic operations, 18 months to pre-war capacity. MacArthur, aware of Casey's unfamiliarity with latest techniques, forwarded the estimate to Lieutenant General Brehon Somervell, commanding Army Service Forces in Washington. Somervell's response came back within 48 hours. Casey's estimate is based on conventional methods. Send him to Naples to observe operations there, then ask him again. Casey spent 1 week at Naples watching port operations. His revised estimate for Manila, 2 months to basic operations, 6 months to exceed pre-war capacity. MacArthur approved the timeline and gave Casey unlimited authority to requisition equipment and personnel from anywhere in the Pacific Theatre. What arrived at Manila made previous operations look modest. The Pacific had different logistics than Europe. Everything travelled by ship across thousands of miles of ocean. But by 1945, American shipbuilding had reached such scale that dedicating dozens of vessels to port reconstruction was routine. 50 LSTs arrived loaded with nothing but construction equipment. 20 Liberty ships carried specialized salvage gear, cranes, pumps, cutting equipment. 10 ships contained nothing but prefabricated buildings, Quonset huts, warehouse sections, even complete machine shops that could be assembled in days. The heavy equipment inventory was staggering. Over 300 bulldozers, 150 mobile cranes, 80 floating cranes, 200 trucks, 50 pile drivers, and countless smaller equipment pieces. The floating cranes included the Navy's newest 350-ton capacity units, capable of lifting entire ship sections in single pieces. But the real difference was manpower. Previous operations had relied on engineer battalions numbering hundreds. Manila received entire construction brigades, specialized units modelled on the civilian construction companies that had built Hoover Dam and the Grand Coulee Dam. These were the Navy's Construction Battalions, the Seabees, legendary for their can-do attitude and industrial efficiency. The 30th Naval Construction Regiment arrived with 4,800 men, all trained in heavy construction. Unlike traditional military engineers who could build, the Seabees were contractors, plumbers, electricians, steelworkers, and heavy equipment operators who could fight. Many had worked on major construction projects before the war. They brought civilian efficiency to military operations. Commander Paul Laig, a former Morrison Knudsen executive commanding the 30th Regiment, looked at Manila Harbour and saw a construction project, not a military problem. His approach was pure industrial engineering. Divide the harbour into sectors, assign each sector to a battalion, give each battalion everything they need, and let them compete to see who could clear their sector fastest. The competition became legendary. Battalions worked around the clock in 3 shifts. When one battalion cleared 5 sunken ships in a week, the next battalion cleared 6. When one erected a crane in 24 hours, another did it in 20. The Seabees turned port reconstruction into a sport, with betting pools on which battalion would achieve the highest tonnage capacity first. The Japanese had destroyed the breakwaters, expecting this would make the harbour unusable during typhoon season. The Seabees solved it by creating a completely new harbour configuration. Instead of rebuilding the old breakwaters, they constructed a massive floating breakwater using surplus ships. 50 old merchant vessels, worn-out freighters scheduled for scrapping, were towed to Manila, stripped of useful equipment, and sunk in a line forming an artificial barrier. The ships were positioned with their hulls overlapping, creating a continuous wall against the Pacific swells. The gaps were filled with pontoon sections chained to the sunken ships. The entire floating breakwater stretched 3 miles and was completed in 22 days. Japanese observers monitoring from the hills outside Manila radioed reports back to Tokyo describing what they were seeing. Their commanders didn't believe them. Building a 3-mile breakwater in 3 weeks was impossible. The clearing of sunken ships reached almost assembly line efficiency. Salvage crews had perfected techniques over dozens of previous operations. They could assess a sunken ship in an hour, develop a cutting plan in another hour, and begin extraction immediately. The cutting teams worked with ruthless efficiency, using shaped charges to section hulls, then lifting the sections with cranes operating in coordinated pairs. The worst wreck in the harbour was the 15,000-ton passenger liner Don Esteban, blown up by Japanese engineers with charges placed throughout the hull. The ship had broken into 3 sections and sank in the main channel, blocking access to 12 major berths. Traditional salvage would have required months to raise or remove the wreckage. The Seabees cleared it in 9 days by cutting it into 63 sections, the largest weighing 240 tons. Each section was lifted by a pair of floating cranes working together, then deposited in deep water outside the harbour. The operation continued 24 hours daily with night work under portable light towers, bright enough to make the harbour look like noon at midnight. Filipino civilians watching the work described it as seeing American industrial power in physical form. The equipment never stopped. When one bulldozer broke down, another took its place within minutes. When a crane needed maintenance, 2 more were already positioning to take over its load. The noise was constant. Engines roaring, metal cutting, pile drivers pounding, explosives detonating. By April 15th, just 6 weeks after operations began, the first Liberty ship was unloading at a reconstructed Manila berth. By May 1st, throughput reached 12,000 tons daily. By June, the port was handling 40,000 tons per day, exceeding its pre-war capacity despite still being only partially cleared. The speed had strategic implications. The invasion of Japan was being planned with the assumption that Manila would provide only limited logistics support in 1945, requiring continued reliance on intermediate bases. The rapid restoration meant supplies could flow directly from the United States to Manila, then support operations throughout the Western Pacific. Entire intermediate bases became unnecessary, freeing up shipping and personnel. General Douglas MacArthur, inspecting the port in May, asked Commander Lake how the seemingly impossible had been achieved. Lake's response was recorded in multiple accounts. "Sir, we had 3 advantages. First, unlimited equipment. Anything we needed was either here or on the way. Second, trained men who knew their jobs. These Seabees had built dams and bridges in civilian life. This was just another job, except someone had shot up the job site before we arrived. Third, and most important, we knew it could be done because we'd done it before. Every man here had heard about Casablanca, Naples, Cherbourg. We knew the techniques, we knew the timeline, we knew it was possible. That knowledge made all the difference." But the real answer, the one Lake didn't say officially but mentioned in letters home, was resources. America in 1945 had so much productive capacity that we could treat a major port reconstruction like a routine construction project. We used equipment in a month that would normally last 5 years. We went through spare parts like they were free because, effectively, they were. Everything we broke was replaced immediately. We didn't optimize for efficiency, we optimized for speed, and we had enough resources to make speed the only consideration. The Japanese High Command, receiving intelligence reports on Manila's reconstruction, ordered an investigation. How had the Americans restored the port so quickly? The investigation concluded that American reports must be exaggerated, propaganda designed to boost morale. No nation could actually rebuild that fast. The conclusion was filed and largely ignored, but some Japanese officers understood. Vice Admiral Takejiro Onishi, who had helped plan the Manila demolitions, read the intelligence reports and recognized the truth. His diary entry from May 1945, found after his suicide in August, captured the strategic implications. The Americans have restored Manila in 2 months. We destroyed it as thoroughly as possible, used more explosives than any previous demolition, and bought ourselves 8 weeks of delay. 8 weeks in which they brought forward everything needed to undo our work, then did it with industrial efficiency that turned our months of preparation into a minor inconvenience. This is why we are losing. Not because their soldiers are braver or their generals more clever, but because their productive capacity treats our maximum efforts as temporary obstacles. We demolish one port, they rebuild it and improve it. We sink their ships, they build 2 more. We shoot down their aircraft, 10 arrive as replacements. The mathematics are simple. We cannot destroy faster than they can rebuild. Every defensive action is merely delay, and delay without hope of changing the fundamental equation is pointless. We should have surrendered after Midway when the disparity became clear. Everything since has been postponing the inevitable. By the summer of 1945, American port reconstruction had become so routine that it no longer made headlines. When Okinawa was secured and its ports demolished by retreating Japanese forces, American engineers had them operational in 3 weeks. When minor ports in the Philippines were needed, they were restored in days. The system had been perfected to the point that port demolition had become essentially pointless. Destruction might delay American operations by weeks, but never long enough to matter strategically. The final demonstration of American capability came at a port that was never destroyed, Yokohama, Japan. When American forces occupied Japan in August 1945, they found Yokohama's port facilities damaged by bombing but mostly intact. Japanese officials estimated it would take 6 months to restore the port to operational status, given the damage to electrical systems, cranes and warehouses. American engineers had it handling cargo in 11 days. The Japanese hadn't understood that Americans didn't need existing infrastructure. They brought their own power, their own cranes, their own warehouses. The Japanese port facilities were nice to have but not necessary. American operations were completely independent of local infrastructure. The statistical summary of American port operations in World War II defies easy comprehension. The Army Corps of Engineers and Navy Seabees reconstructed or built from scratch 271 major ports and harbours worldwide. They cleared over 3,200 sunken ships from harbours and channels. They erected over 8,000 cranes of various types. They laid over 45 million square feet of steel planking for all-weather surfaces. They constructed over 115,000 prefabricated buildings for storage and operations. They drove over 2 million tons of steel piling for pier construction. They moved over 800 million cubic yards of earth in dredging and site preparation. The equipment consumed was equally staggering. The Corps of Engineers and Seabees used 14,000 bulldozers in overseas operations, more bulldozers than existed in the entire world in 1939. They operated 6,000 mobile cranes, 4,000 floating cranes, 18,000 trucks specifically allocated to port operations. The fuel consumption for port reconstruction equipment exceeded 400 million gallons during the war, enough to fill a tanker fleet. But the most telling statistic was throughput. In 1943, all Allied ports worldwide handled approximately 2 million tons of cargo monthly. By 1945, American reconstructed ports alone were handling over 15 million tons monthly, a 750% increase. This cargo sustained 8 million American troops deployed worldwide, plus supplied millions of Allied troops, and supported civilian relief operations across liberated territories. The German final assessment of American port capabilities came from General Oberst Alfred Jodl during his interrogation after Germany's surrender. When asked what single factor most contributed to Germany's defeat, his answer surprised interrogators: American logistics. Specifically, their ability to reconstruct ports faster than we could destroy them. Every German defensive plan from 1943 onward assumed that denying the Allies port facilities would limit their offensive capabilities. We demolished ports thoroughly, according to advanced engineering principles. The Americans rebuilt them in weeks using methods we considered crude but which worked. By 1944, we understood that port demolitions brought us only temporary delays, but we continued because there was no alternative. The psychological impact was devastating. Our soldiers knew that no matter how thoroughly we destroyed infrastructure, the Americans would restore it rapidly and continue their advance. This knowledge undermined defensive morale in ways that direct combat never did. How do you maintain fighting spirit when you know the enemy can undo in weeks what took you months to destroy? The Americans won because they applied industrial production principles to every aspect of warfare. They built ports like Ford built automobiles, with interchangeable parts, specialized workers, and assembly line efficiency. We approached warfare as a craft. They approached it as industry. In a long war, industry always defeats craft. The post-war analysis by the US Army identified several factors that enabled the unprecedented reconstruction speeds. First was equipment superiority. American construction equipment in 1945 was generations ahead of 1939 technology. The bulldozers, cranes, and specialized machinery developed during the war would remain state-of-the-art until the 1960s. Much of it was designed specifically for rapid port reconstruction based on combat experience. Second was doctrinal flexibility. American engineers weren't bound by traditional engineering principles that demanded permanent, efficient solutions. They embraced temporary, wasteful methods that achieved operational capability quickly. This required overcoming decades of engineering education that emphasized optimization and efficiency. Third was resource abundance. American industrial production was so vast that equipment and materials could be treated as essentially disposable. If using equipment at triple its designed capacity meant it wore out in months instead of years, that was acceptable because replacements were always available. Fourth, training quality. By 1944, American engineers were veterans who had rebuilt ports under every possible condition. They arrived at new demolitions having seen worse, knowing what worked, confident in their ability to succeed. Fifth, and perhaps most important, was integrated logistics. Port reconstruction wasn't an isolated activity. It was part of a comprehensive system that included equipment manufacture, transport, personnel training, and tactical doctrine. Every element was designed to support rapid reconstruction. Ships were built with port equipment preloaded. Engineers trained specifically for harbour clearance. Tactics assumed ports would be available quickly. The entire system reinforced itself. The economic analysis was equally revealing. The United States spent approximately $1.2 billion on port reconstruction during the war, roughly $22 billion in 2024 dollars. This included equipment, personnel, materials, and transportation. The return on this investment was incalculable. Every port restored enabled faster troop deployments, sustained larger forces, shortened the war. The strategic advantage of being able to use any captured port within weeks gave the Allies operational flexibility that the Axis could never match. More subtly, the knowledge that ports would be rapidly restored influenced strategic planning throughout the war. Amphibious operations were planned assuming port access would be available quickly. This allowed operations that would have been logistically impossible under traditional assumptions about port availability. The entire island-hopping campaign in the Pacific depended on rapid port reconstruction. Each captured island's ports were restored immediately, becoming the logistical base for the next operation. Without this capability, the Pacific advance would have required years longer. The Germans learned expensive lessons about American engineering capabilities. Every demolished port was rebuilt, usually better than before. Every obstacle was overcome with overwhelming resources. Every defensive advantage was temporary at best. The realization that infrastructure destruction was pointless came too late to change German defensive strategy, but it demoralized troops who understood that no matter what they destroyed, the Americans would simply rebuild it. In September 1945, Japanese engineers were brought to survey Manila Harbour as part of a reconstruction planning. They found the port handling over 50,000 tons daily, more than it had ever processed before the war. The Japanese had used 5,000 tons of explosives to destroy it 6 months earlier. American engineers asked the Japanese how long they estimated reconstruction had taken. The senior Japanese engineer examined the facilities, calculated mentally, and answered 18 months minimum, possibly 2 years. When told the actual timeline was 2 months, he refused to believe it. He insisted on seeing documentation, photographs, work records. After reviewing the evidence, his response was recorded by the American officer translating. "This is not possible with our methods and resources. You have achieved in 2 months what would take our engineers 2 years. The equipment you brought exceeds what all of Japan possessed before the war. The manpower you deployed to a single port exceeds our entire engineering corps. You have solved a problem we thought was fundamental, that destroying infrastructure creates permanent delay. You have made infrastructure temporary and replaceable. This changes everything about defensive warfare. There is no point demolishing what can be rebuilt immediately." The Manila operation marked the peak of American port reconstruction capability, but it was not the end. After the war, the techniques developed under combat conditions were applied to peacetime reconstruction. American engineers rebuilt ports throughout Europe and Asia, using the same methods that had worked under fire. The Marshall Plan's success depended partly on rapid port reconstruction that enabled efficient cargo flow. Ports that had taken years to build originally were restored in months, using American methods and equipment. The technology developed for wartime port reconstruction became the foundation of post-war construction equipment industry. Companies like Caterpillar, Letourneau, and International Harvester leveraged their wartime equipment development into peacetime commercial success. The bulldozers, cranes, and earth-moving equipment that had rebuilt Cherbourg and Manila became the machines that built the interstate highway system and countless civilian projects. The techniques pioneered by combat engineers became standard commercial practice. Prefabricated construction, modular design, heavy equipment operation, all were refined under wartime pressure and then applied commercially. The modern construction industry's speed and efficiency traced directly to World War II engineering innovations. The doctrinal lessons were equally enduring. The principle that speed trumps efficiency in critical situations became embedded in American military logistics. The willingness to use temporary solutions and accept waste to achieve rapid operational capability remained doctrine. The emphasis on overwhelming resources rather than elegant optimization continues to characterize American military engineering. But perhaps the most important legacy was psychological. American forces learned that no obstacle was permanent, no defensive position unbreakable, no infrastructure destruction meaningful. This confidence in being able to overcome any challenge through applied resources and determination became a defining characteristic of American military operations. The knowledge that logistics would always be available freed operational planning from constraints that limited other militaries. For the Germans and Japanese, the lessons were harsh. Infrastructure destruction that should have provided months of defensive advantage provided weeks at best. The careful demolitions that consumed enormous resources and time were undone with apparent ease. The discovery that American industrial capacity could overcome any defensive measure faster than defenders could implement new measures was demoralizing beyond any battlefield defeat. Because it meant that no defensive strategy could succeed. Every position was temporary, every delay was brief, every sacrifice was merely postponing inevitable defeat. The final German assessment came from Albert Speer, Minister of Armaments and War Production, during his Nuremberg testimony. Asked about factors that determined Germany's defeat, he mentioned port reconstruction specifically. The Americans possessed not just superior production, but superior capability to employ production strategically. They understood that in modern war, logistics determines outcomes. Their ability to reconstruct ports meant they could land anywhere, capture any port, and have it operational within weeks. This gave them strategic mobility we could never match. We could destroy their facilities, but we could not deny them the use of those facilities long enough to matter. This was true everywhere. In North Africa, Italy, France, everywhere they landed, within a month they had ports handling more cargo than we thought possible. By 1944, we understood that attempting to deny them ports was futile. We demolished infrastructure because defensive doctrine required it, not because we believed it would succeed. The American answer to every problem was more equipment, more men, more resources, and they had enough that more was always available. We fought an industrial war with a military that thought in pre-industrial terms. We optimized, and they overwhelmed. The outcome was never in doubt once we understood what we faced. In the end, the story of American port reconstruction in World War II is the story of how industrial capacity applied with determination and intelligence overcame every obstacle. German and Japanese engineers had created demolitions that should have taken years to overcome. American engineers rebuilt everything in weeks using methods that traditionalists considered crude, but which worked perfectly. The flying concrete, as some called the prefabricated structures, and the diving mechanics, as the salvage crews were known, achieved what everyone said was impossible. Not through genius or secret technology, but through overwhelming resources, proven techniques, relentless execution, and complete confidence that no problem was unsolvable. When German commanders looked at the ruins of Cherbourg in July 1944 and then saw it operating at full capacity in October, they understood they were facing something unprecedented. Not just an army, but an industrial system that could absorb any punishment, overcome any obstacle, and maintain any operation indefinitely. The mathematics was simple and brutal. America could rebuild faster than Germany could destroy. In that equation lay the certainty of defeat. The thunder of American reconstruction, the constant noise of bulldozers and cranes and pile drivers, became the sound that haunted German defensive positions, because it meant that no matter how thoroughly they prepared defences, no matter how completely they demolished infrastructure, the Americans would arrive, rebuild, and continue advancing. The only variable was how long the delay would be, and by 1945 everyone knew the answer. 2 to 3 weeks, sometimes less. Not months, not even 1 month. Weeks. And then the supplies would flow, the offensives would resume, and the line would move forward again. Unstoppable, inevitable, mechanical. Industrial warfare in its purest form, where production defeated everything else.